looking for an introduction to Spring Pulsar, you're in the right room. I'm Chris Bono. I'm a software engineer at VMware on the Spring team.
And I'm Christophe Bornet. I'm working at Devnexus. I'm an Apache Pulsar committer, and my work is to work full-time on Apache Pulsar, make it grow and become an even more awesome project.
Cool, so we're going to spend the next hour, we're going to give you an overview of Spring and Pulsar. We're going to show you how to use Spring Pulsar, talk about the architecture, what the benefits are, and then our favorite part's the live demo. So we're going to get in here and do some coding and see if we can break anything. And then we'll follow that up with a conclusion and some questions and answers. Here's the introduction.
Okay, so for those of you who were not at the team talk just before, what is Apache Pulsar? So Apache Pulsar is an open source streaming platform. It's fully distributed. It's built for the cloud. It has some awesome features such as multi-tenancy, tier storage. It's high performance, and it has the particularity of being able to handle two streaming use cases, the message queuing use case and the streaming use case. So the message queuing is more traditional messaging such as RabbitMQ, AMQP, ActiveMQ, and streaming is what is done, for instance, in Kafka. Don't mix the two. If you use Kafka to do message queuing, you are doing it wrong. So if you want to do both, you can use Pulsar. And Pulsar has a lot of momentum. It is more and more popular, and it has become an Apache top-level project in 2018. And there are more and more contributors, including me, that contribute to it.
And so what is Spring for Apache Pulsar? So Spring for Apache Pulsar basically lets you use Pulsar in a Spring-based application really easily. At Spring, we love messaging. We have support for Kafka via Spring Kafka. We support JMS through Spring Framework. We support Rabbit through Spring AMQP. And so this brings Pulsar into the Spring Pulsar ecosystem as the others. And so the backstory is why are me and Christophe standing here on the stage together? It's interesting. So Sobi Chaco is my coworker, and he's the co-lead of Spring Pulsar. He kicked off the project, and I joined shortly after. And one of the decisions we made up front was to go the imperative route, use the imperative vanilla Pulsar client right up from the start. Pulsar client does have an imperative or a non-blocking completable future-based API. Oh yeah, there we go. But we decided to go imperative and just go from left to right with some heavier use cases instead of trying to do both at the same time. And about 5 minutes into that decision, we realized that wasn't going to work because people were filing issues on GitHub already. Where's my reactive? Where's my reactive? And if you know anybody who uses reactive, they have to have their reactive. And so we were kind of at a dilemma as to what to do at this point. Sobi went to the Pulsar Summit about the same time and ran into some old friends from DataStax, Laurie Hittari and Christophe. And it just so happens that they had a reactive client that they were going to donate to. They were about to open source it into Apache, and also were willing to spend the time to hook it into Spring Pulsar so that our problem was solved. And I had a new best friend, which is Christophe Bornet. And then I said, wait, what's his name? Christophe Bornet, right? My name's Christopher Bono. He's Christophe Bornet, right? Hold on. I'm in Austin, Texas. He's in Bordeaux, France. I love coding. He loves coding. I love meme code reviews. He loves meme code reviews. I love testing. He loves testing. And so it's like this French multiverse counterpart. And we've had a blast over the last few months just hacking on this stuff. Yeah, and we paired with DataStax and on the reactive side. Now let's go into an overview.
Okay, so I will talk about the concepts in Apache Pulsar. So in Apache Pulsar, you have producers and consumers, or you can call them publisher and subscriber, that exchange messages over a topic. And the topic is same kind of, is just like a file or append-only file, or call it a log or a ledger. And the producer will append messages to this topic, and the consumers, they will read from the topic, and they can read from different positions, or they can be grouped into a group of consumers that will read from a given position. And this position, if you know Kafka, in Kafka it's called an offset. In Pulsar, it's a much more evolved concept, which is a subscription. Why do I say that it's more evolved? Let's see the different kind of subscriptions that exist in Pulsar. You have the exclusive subscription. So in an exclusive subscription, only one consumer is able to connect to the subscription. I will skip the shared one for the moment and go to the failover. The failover is a bit like the exclusive. Only one consumer can consume at a time on the subscription. But if something goes wrong and the consumer fails, then another one can take the leadership and continue the consumption. So the failover mode is what you know in Kafka as a consumer group. That's exactly the same. What doesn't exist in Kafka, but is more what you find in RabbitMQ or AMQP engines, is the shared subscription. The shared subscription implements the competing consumers pattern. So you have multiple consumers, and they will receive a part of the messages. And what is important is that each consumer can acknowledge individually the messages. So this is not something you can do with an offset. This is why a subscription is a better object. So when the topics, they are served by the brokers in Pulsar, and I talked about the producers and consumers. And to create these producers and consumers, there are existing APIs and clients for a variety of languages. And of course, the ones that are interesting for us today are the Java clients. There are two clients, so the imperative one, which is the historical one, and we released the reactive client not so long ago. And this is what is used by Spring. So the Spring Pulsar project, you can already get value by just using Spring Pulsar and using the Pulsar client directly, because Spring Pulsar will auto-configure the client, and you will get type-safe configuration. So even if you want to stay close from the Pulsar client, you already get value from Spring Pulsar. Next, if you want to have a level of abstraction higher using Spring concepts, you have the Pulsar listener and the Pulsar template. So if you're familiar with Spring Data, Spring Kafka, etc., you've already seen something template. So there's a GDBC template, Mongo template, Cassandra template, etc. So there's the Pulsar template. This is used to produce data to Pulsar. And the Pulsar listener is an annotation that you put on a handler function, and it will automatically create a consumer and call the handling function each time there's a new message coming. We have counterparts for reactive, so of course the reactive Pulsar listener and the reactive Pulsar template. So the reactive Pulsar template will have APIs that use the reactive streams publisher. So quickly, some sample codes. So this is a Hello World. It's a working application. You can copy and paste, and it works. It's using the Pulsar template to send something. We have a listener to read from the message. I don't spend too much time on this because we will have the demo just after. For the reactive part, just showing that it looks really similar, except that now we have the reactive Pulsar template, the reactive Pulsar listener, and we have mono interfaces. We need to build the reactive part using the reactor library.
Cool. I think this is working now. So what some other features that we have on top of the basic Pulsar, produce and consume is Pulsar IO, Pulsar function support. So Pulsar IO is, if you've used Kafka Connect, it's Pulsar's answer to sourcing and syncing data to and from Pulsar topics. Pulsar functions is somewhat similar. Under the hood, they're somewhat similar, but it's a way to take your Java code, run it actually on the Pulsar cluster, and you can hook up through Pulsar IO and Pulsar functions. You can get yourself a streaming pipeline where you have sources, processors, and sinks. We also support error handling in addition to what Pulsar native supports. We have some other niceties on top of it. And Pulsar Reader API support. So we've talked about consumers where there's a subscription, and as you go and you ask the subscription for more data, it walks across that subscription, make sure that you get the messages as they come, and you don't have to remember where you were at in the topic. Pulsar Reader is more flexible and powerful whenever you need to get in and say, I'm looking for these specific sections of data, or I need to start at this particular, quote unquote, offset position. And so we also auto-configure the reader clients. We also do some automatic schema and topic detection / resolution. All this is saying is that whenever we get a message on the framework, and whether it's going in or out, we can look at that message and say, okay, it's a primitive, I can set the schema for this. Schema is just the encoding that's used along the wire as it goes to and from topics. For complex objects, we'll use JSON by default. And then we also have the ability to do default settings inside the application YAML such that, for instance, if I have a user object, I always, by default, want it to say, hey, it always goes to and from the user topic, and then its schema is always Avro. By setting that up in the YAML, I don't have to, when I go and use the produce and consume API, I don't have to go and set user topic, schema JSON, user topic. It simplifies the use, basically. What else? Spring Cloud Stream Pulsar Binder. So if you've used Spring Cloud Stream, Spring Cloud Stream is a way to bind your Plano Java functions, suppliers, and consumers to your messaging middleware. In this case, Pulsar is the interest. And so, imagine if I have a Pojo function, I can say this input parameter comes from the user topic. Wow. This output parameter goes to the registered user topic, for instance. And so through some configuration, you can actually wire that up. I'm just going to do this here. GraalVM native image support. So if you've been living anywhere besides under a rock for the last year, you have heard something about GraalVM native images. And we're not going to go into what all it is, but the takeaway is you take your Java program, you run it through Graal, it spits out executable, it starts up very fast. And that's the aspect we're going to show. The binder as well as the GraalVM, we're going to go through the things that we've talked about, we're going to demo here shortly. Built-in observability. We're sitting on top of, the framework runs on Spring Framework 6, Spring Boot 3. We also hook onto the newer micrometer observations API. So on the imperative side, when you use it, you'll get free tracing and metrics. The reactive side support is coming soon. Why would I use it? So this is the question. Well, I know about the Pulsar client. Why can't I just use that directly? It seems like do I really need this framework? And you could use the Pulsar client directly. It's a nice API. I use it. I think the framework's beneficial for two things really: increased developer velocity and developer experience. There's 1,000 definitions for these. For me, that developer velocity is how fast I can take something from thought to production in a quality manner. And developer experience is how good is my life along that journey? Am I happy using this, or do I dread having to open this up to deal with this again, or am I excited? And I've found that because of the fact that we sit on top of the Spring Boot foundations and just Spring in general, there's a huge community of users. We have the auto configuration, the type safe configuration properties. Those types of things, and the consistency makes it, I think, worth using. Ooh, all right, the live demo.
So, yeah, it would be better.
Okay, it would be better. Oh, there it goes, it works. Okay, So we wanted to demo something that's not a stock trading app that geolocates flight data and tweets everybody in the audience, because we have limited time. So we're not going to do a foo or a hello world, but we're going to do a user registration. And so we're going to take a user, we're going to put it into a topic, we're produce it, and then we're going to consume it out of the topic. And then we're going to take that same thought, produce, consume, and we're going to walk across imperative with some improvements, reactive. We're going to throw Spring Cloud Stream in it, and then we're going to run it through Graal, and then then we'll be done. Okay. We're going to use our handy dandy start.spring.io so Spring Initializer is a way to bootstrap your application. Is that big enough? And so we're going to go here and say Gradle, Java, boot 305. I'm going to say change this up a bit, Acme, Pulsar, and packaging jar, Java 20's out, nice. Okay. Can't believe that. Okay, Pulsar. When we type in Pulsar, here's our offer, here's the things we can get with Pulsar. Let's do Spring for Apache Pulsar. This is the imperative support. We'll start there. We're going to generate, it's going to zip us a zip file out here. We're going to go over here and, yeah, it turned off. Let's do,
yeah, so unzipping the file.
Yeah. Move.
Okay, moving.
Unzip.
And starting.
Okay. I'm also going to start up Pulsar start.
So we start Pulsar with Docker.
Okay.
I'm now going to IntelliJ and opening the project.
Okay. And we will clearly open this up bigger.
Okay. So if you want to go in the front, you maybe because there will be code. So if we look at the Gradle file, yeah. So we see what was generated. We see that the starter for Spring Pulsar was imported.
Yep.
And we know that we will use JSON, and this was not possible to use to add it simply with the starter Spring.io. So we add the starter for JSON.
Yep. Let's pop Gradle.
Yeah. Refresh, and now we can start coding our application.
So exciting. Let's create a user.
So we will use a user. We're using the records. So if you don't know about records, go check. It's a really nice way to create immutables in Java. It was really lacking, and we will use it for the demo. So we have a user. It has a UID and a username, and we will create a user service.
Wow.
And that space.
That's funny.
And you need to rename that.
Yeah.
It's crazy. It's all allowing you to to create a class with a space.
Flexibility.
Okay, so we add the service annotation, and now we will want to create we can import the object mapper.
Not that one. There, that one. Okay.
Yeah, that's the one. Okay. And we will have a service that will enable us to get a user from somewhere. Let's call it single user.
Okay, let's look at this.
Okay, so we first write a function that will get a single user async. So we use a template because there's a lot of code to remember, and it's faster. We are using a service on the internet because we like to live dangerously, and and so it's a web service that just generates random users. Yep. We'll get that with the HTTP client of the built-in HTTP client, the new one from Java. We're not using web client because it would mean importing a lot of stuff.
We want to keep it simple as we're going to step through every step we go. We're going to look back in that build Gradle, and we're going to see what's added as we add stream, as we add that, and what web flux and web client makes things kind of confusing from the beginning. Cool. Thank you, Christophe.
And you see why we use the object mapper. It's to convert what we get from the website into our user object.
Create a single user API here.
So yeah, we also create single user, which will simply get the user async and join it to have it imperatively.
That would have been bad.
Yeah.
Okay.
Okay. So now we are going to be able to use it. What we want to do so first is to publish users that we get from the web and to publish them to a Pulsar topic. So we import our service, we import the Pulsar template.
And I have to say something. So I don't usually do field injection. I'm just doing it because it's a demo and it's concise. And so if you see me do anti-patterns through here, like do system.outs or auto-wired, I'll call them out because don't copy and paste the code. It's yeah.
We know it's bad.
And it's okay because we know it, right? It's bad.
And this will not go to production.
This will not go to, oh wait, oops, no, I'm kidding. Okay, so now let's call something void source user into Pulsar. How about that? And we'll say our message ID equals user template.send user topic user service single
so
user.
the wiki is not working anymore. Okay, so you see we are using the template. It's simple. We say which topic, what do we want to send, the schema.
That's the buck. Cool.
And we will print the value of the message ID that we receive. So when you send something to Pulsar, it responds to a message ID. And this is what we will print to the console. Again, don't use system out print.
It feels so good to use it though.
At home, use a logger, but here it's just for a demo. Okay, so we will schedule this to run every second with an initial delay of 2 seconds. We have the enable scheduling annotation so that Spring knows about it.
All right, I have a theory.
And now I think we can run the code. And hopefully it works.
Yeah.
Okay, so we produce messages.
Woo!
Cool.
Amazing.
We can prove that we published something.
Yeah. Let me do this real quick. I forgot to pull this command up. You do not want to watch me try to type this. Okay. We want to use the command line utility to show that we're actually getting the data from the topic and it's not overall here inside of Spring Pulsar. So Pulsar has a command line client called Pulsar Client, and we're going to go hit that on the Docker server. On the Docker server. All right. So let's do this. Let's see DPS. Okay, do that. Docker exec.
Okay, so it's starting the consumer, and we see that we get the users. So with a random username and a random ID, UID.
Yep.
So cool. We have messages coming into Pulsar. Now what we want to do is to consume them, and we will consume them in our application. So using the Pulsar listener.
Log users.
Yeah. Let's give a name. So it's log users from Pulsar topic. It will take as input users, and we will just print those users to the console. And this is where we use the Pulsar listener annotation. We say which topic, so we consume from the same topic where we published. And we specify that the schema will be JSON. Rerun this. And so now we have produce, consume, produce, consume, produce, consume. So the thing we had in the Pulsar CLI, now we have it into our application.
Yep. Cool.
Cool.
So now one thing I noticed is the boilerplate we kind of talked about with here we have JSON, schema type JSON. We know that the default schema type for complex objects is JSON, so we could drop that out. And that's an improvement, right? So we do that and push play again. We should see the same thing. We're kind of going for the status quo. Every step we want to see the same thing, the same thing. Yep, we got it. Yep. Okay, so that was that. And I know one other thing we can do to another improvement is if we come over here to
rename.
Yeah, let me rename this. Start Spring IO drops out a properties file. I like YAML better than properties. And so we talked about doing those defaults, right? And so if I do, look at all these properties. Nice. Okay, Spring property defaults, type mappings. We could say, okay, message type of user. Anytime I have a user object, I'm going to go to the user topic. Likewise, if I wanted to do something besides JSON, I could also say schema info, schema type, avro, and that would prevent me from having to do all this on the API calls. We know JSON's the default, so we'll keep that. Let's also do this. Get rid of some of this extra logging. And now, if we come back to user service, no, not user service, app. Let's try it again. Oh, it's just going to say the same thing. Yeah, let me do the whole removal. There's another simplification we're doing for the calls here. On Pulsar Listener, there's a property for subscription name, which is important. By default, it uses exclusive and it generates the subscription ID. So we just pulled it out for the demo purposes for less things to see. And so we removed the user topic. Now it's just Pulsar Listener, and then now it's just send the data. Let's try it.
So an interest also of putting externalizing the topic into the application in YAML is that you can, in production, easily change the topics and by configuration.
Yep.
Cool.
Okay,
so still working.
And so we've cleaned up our use, and then we're still using imperative, and now suppose we have a requirement to do reactive.
Yeah, so we want to do reactive because it's cool. So we go back to Spring, we will add the dependency for reactive. Okay, instead of regenerating, we will just copy-paste the Gravel file. And we see that we got the starter for reactive, and we add back our starter for JSON.
Gradle.
We pop Gradle.
Now let's do.
Okay, so we need a service that returns reactive things. So we can build one easily with a flux of user. Call it.
Multiple
so
users.
We call it multiple users. Okay, we take it from the async method we had. So it's just single user async. We will map. Yeah, we delay every second. So this will be used to recreate what we had with the schedule. And
that's it.
Oh yeah, and that's it. We can use it in our application.
Do this.
We will wipe everything that we wrote before and start from fresh. We'll just keep the user service. Instead of the Pulsar template, we use a reactive template.
That's it.
Okay, and we go back to source our users into Pulsar. And this time we will call our user service multiple users. What we want to do is to map them to message spec. So message spec is what you push to the API for reactive. It's a wrapper around the value. And then we pass this to our Oh yeah, before. No, each. Do
Oh,
on
yeah.
each. It's do on each.
Yeah, let me.
But
Yep, you're right.
you need to ask before you.
There we go.
Yeah, but before we need to ask to send to the Pulsar template.
Mm-hmm. There we go.
Okay, so we get this message spec and push them to our user template. And send.
It was user messages. Yeah. Okay. And then because we got rid of the extra parameters, we can do things like this. Right? Oh no, not that.
No.
Like this.
Yeah.
No, not that. How about
but
the third time the
charm? Why is it not happy with this? I think when you do as. Hold
on 1 second. Expand, replace Lambda. There we go. It's just because it was. Okay. It's. I'm ahead of the. I made errors down below.
Okay, so we know that the users. We have the configuration to send the users to the topic, and the schema is automatically set, so we can call as directly, and then we will print for each message that is produced. We will print it to the console.
Yeah, message send route. Get message ID. Interesting. Okay. I think it's confused here. Send result. Send result, and then sys out that. Send result dot get message. Guys, we're just going to drop that. Okay.
What's
and then call the subscribe. Right.
Yeah.
That's it.
Okay.
Cool. And so once we hit that subscribe, it starts to flow through the pipe, and then we just need to hit this once, right? We need to kick it off like prime at one time. So let's do a application runner. And so this is, if you're familiar with Spring Boot, this is a way to do something once after the app started. A simple way. Turn args. Well, okay. So the theory is we push the play button and wait, no. Let's do the consumer.
The consumer part. So we have our producer part, we will do the consumer. So same as before, we log users from Pulsar, topic, still a user. Okay, and this time, instead of returning a void, we will return a mono void. We print the user we get, and we return a mono.empty.
When will I use this one?
So if you return mono.empty, this will acknowledge the message, and the framework automatically will send something to Pulsar to say, yes, the message was processed and it is acknowledged. If you return an error, then the framework will negatively acknowledge, and the message will be rejected and sent to another consumer. We had our reactive Pulsar listener, and now we can run the code. Something I can add about the mono is that it's part of the reactive chain.
It didn't do something. Hold on. Let's see. See what's printing out? Yeah, you got something. So we'll continue on and we'll flex.
So when you return the mono, actually it's part of a reactive chain. So when we've put a reactive Pulsar template, it has created a reactive chain, subscribe to it, and it gets the messages, and then it calls the handler in a flat map. So this is why the input of the mono is a user and not a mono user, because we do not need to have a reactive object. We can work directly on the user that comes into the flat map function.
As flux, what is it not calling? Here, let's do this as. Right? What is it not liking? Oh, geez, okay. Really? Okay.
Oh, there's already a message.
Yeah, okay. Should do one each. Why is it seeing this as a flux? What are we missing here? Messages.map, right? This is a flux and message spec, right? And then
Yes, that's okay.
Flux of send results, and then do
You have a flux.
do on next, right?
Yeah, do on next.
Okay. Consumer. That was the problem. Okay. Right there. Okay. Yeah.
Okay. So
Not do on each. Do on next.
otherwise, you're working on the signal.
Yeah. Yeah.
Okay. So produce, consume, same as before.
And then also just to for parity with what we did before. This is why IntelliJ wasn't lying. It was I should have listened. Okay.
Yeah. So we get the message ID from the same result.
Yeah. Produce, consume. Cool. So you might notice if you look at the if you know a little bit of reactive and you look at this reactive Pulsar listener, you're seeing that doesn't look very reactive. There's a mono. I see that, but like this isn't a mono. Where's the flux? And so you want to talk about a little about that, Chris?
So here our handler handles messages one by one, but maybe sometimes when you're doing reactive, you want to act on the flux, not only on one message of the streaming. So there's also the possibility to have a flux as input, and you work directly on the full flux. Okay, and so instead of returning a flux of void, we need to return a flux of message result, because we need to say to the framework, do we want to acknowledge or negatively acknowledge? We cannot send an error into our flux. This would be bad. So instead, we wrap in the message result whether we want to acknowledge or negatively acknowledge. So this time we have our flux. We want to print.
Yeah,
users, maybe call it users. Flux.
Yeah, I'll switch in a sec. So map and then message result dot. Okay.
Yeah. Right. So there's a utility in the reactive client to acknowledge directly on the message result. So you get the result and you can acknowledge it right away.
Yep. So.
Okay, and now we run, and we produce, consume, same as before.
Awesome.
Cool.
So we went through imperative, we switched it, we improved that, then we went and switched it to use reactive, and now let's do something interesting with the user. So we said we were going to do a user registration, so let's create something called registered user, public record, registered user. It is a user. This angle is really weird to stand up like this. I would kill myself in my back. Okay, tier. And then down here, let's have a public enum tier. No money, a little bit of money, all the money. Wow, all the money. Okay. Sweet. So our super rich object model here, as you can see. So what do we want to do? Let's say we're just going to talk in terms of Java at this point. I'm going to have a function that's going to take a user. It's going to create a registered user. I want to take that user from the user topic. I want to put that registered user in the registered user topic. And so let me go over here. It's a Pojo, and let's call this register user. Let's go ahead and flesh this out a bit and say, okay, return this function that's going to take a user. It's going to return a new registered user of user, and then tier. You know what? I'm going to do something. Another super anti-pattern. Var rand was new random, not so random. Okay. And it's in line in the method, but it's called once because it's a function. And so this will look as if it's a random number generator. All we want to do is get a random tier to put in here. So tier.values, and then rand.nextInt bounded by tier.values.length. So maybe one more. Maybe that's nice. There you go. Okay. So now that we have this function that will take a user and return a registered user, let's do something with it. How do we bind those topics like we wanted to do? Or there we go. So Spring Cloud Stream is a good fit for this. It takes it, you take this POJO and say this input comes from this topic, this output goes to this topic. That's exactly what we want to do. So let's turn this into a bean first. All right. Let's also go back to our start Spring IO and add in the dependency that's required. So Pulsar. We'll explore a little bit here. Same thing. Let's copy this. Come back over to build a Gradle. Drop it in. What was added, Christophe?
We need to add JSON.
Yeah.
So we added the Spring Cloud Stream binder and the Spring Cloud Stream dependency. So Starter Spring.io detected that we wanted to use Pulsar.
So let's go bind this.
Yeah.
Yeah. Thanks. So let's go back to our friend application YAML. Let me get this logging business out of the way. Because these properties, we're going to use Spring Cloud Stream properties to do all the binding. So Spring Cloud function definition. So this is the name of the function, register user. The next thing we do is we call stream bindings. This is where we say, okay, register user method input parameter, the first one, its destination is going to be user topic, right? And then we have to tell it a little bit more, say, okay, it's a consumer. When it consumes that off that topic, we're going to use native decoding. And so for Spring Cloud Stream, native encoding, decoding is, if it's not native, Spring Cloud Stream will handle it using just typical Spring converters and serializers. We're saying, no, we're going to go ahead and handle it on the Pulsar side of things. That's what we've been doing so far with our JSON. We're going to continue doing that. And so likewise, let's do register user. This is output parameter, the first one. And then destination, where do we want to write it to? Registered user topic. Do you need to tell me anything else about the producer? Yes, use native encoding. This next little piece, we do have to tell the Pulsar specific binding a little something. Bindings. We need to say register user, the first input parameter. It has its consumer has a property of message type user. We're working on making this a little more streamlined. So this latter part, we can probably use some type of type inspection to figure out what these types are. It's just buried down a little bit, and it's going to take a little bit of work. So producer, message type, and this one is registered user, right? So to recap, here's my function name. For this first parameter, go to user topic. For the second output parameter, write it to registered user topic. Here's the types that I'm using. And so if we come back here to Pulsar application, also let's change one more thing up here. Let's move to, instead of user, let's switch this to registered user. And then we'll have to also adjust the topic name. Reg user topic. Cool. Okay, the theory is we're going to push the play button and we're going to see registered users now instead of regular users.
Starting. Okay. Produce consume. Yeah, it's working. And
little money.
And we have the tier, which is random.
Okay.
For each user. Okay, nice.
And so
can we do better?
We can do better.
What's the starting time for this function?
Let's look at this. The startup time, if you notice, of the app was Pulsar application started in 1.77. Let's call it 1.8 seconds. We can do better with the help of GraalVM.
Yeah. Okay. So showing quickly GraalVM, going back to startspring.io. Not yet. Yeah.
Oh yeah.
Using the correct JVM. Okay, so GraalVM, adding it to our dependencies. Let's explore. Okay, what did it add?
Let's find out.
We'll see later. Okay. So again, we add our JSON starter
Gradle.
and Gradle. And what did it add? The plugin for GraalVM, so that we can compile to native. So yeah, to give some word on GraalVM, it's a way to compile Java code to native code, and so you don't have to start up the VM. It will start much faster. So what we do is to build native, which is the job that was imported by the plugin.
Oh, what? Oh, did I not pop Gradle? It's native build, I think. I bet you it's native build. It's probably native build. Native build, is it? Or maybe it's not. Yeah. Wrong command.
I usually use Maven, so I wouldn't have that.
Why don't we, so we know that this is going to take a minute or two to build, so we trade, startup time for build time with Graal typically. And so while that's running in the background, let's jump back over here and talk about what's next for the framework. So transactions. So Pulsar has built-in nice, pretty strong transaction support built into the application. We want to extend that to the framework so that you can use your @transactional Spring, annotations, things of this nature, and extend that into the framework. Also, automatic failover support. The Pulsar client has the ability to wire in several URLs, service URLs, so if one goes down, it can automatically fail over to the other one. We want to pull that configuration up into the application YAML so that you can get easy access to it. This next 3 bullet items here is really about where the project's living right now. So if you've looked in the repo, you know that it's in an Spring experimental projects is where it's living right now. And there's 3 things in there. There's the core, there's the auto configuration we've talked about, and then there's also the binder, the Spring Cloud Stream binder we've talked about. And so everything's ready and production ready to run. It is living in that experimental repo, but not for long. Those 3 pieces are being broken up into their respective homes, and core is moving into its own Spring projects. This is in process right now. That'll be done in the next month, probably. The auto configuration is moving into Spring Boot proper. There's a pull request in for that, and so we're looking probably around the 3.2 timeframe. Midsummer is when we can start seeing that inside of Boot. And then the binder is moving into Spring Cloud Stream proper as well, and we're aiming for the 4.1 release. So soon it's happening, and they're going to go all 3 of the pieces are going to go live in their respective homes where they were originally designed to go. And so what are we building next really is the one that we really want to know about is what y'all want us to build. We've up to this point we've built what's important to us and what we think will be important to you, but get on there in GitHub or in Stack Overflow and tell us what you need and what you want to see, and we're going to build it. And so, what about GraalVM? Okay, what do we have here?
Okay, so build was successful.
Okay,
we can run the executable. So we have the path which was given by the build.
Let's do it. There's a bunch of output usually, and so when you start playing with Graal, you can go look at all the details. It tells you what it could and couldn't do, how it could do better, what you need to do, etc. So
okay, so called Pulsar starting.
We'll talk about that in a sec.
Some add opens missing, but it's okay, still running.
Here's the thing.
So
0.2, 1.7 to 0.2, 0.26, right? It's much faster than startup, so it's real, and it's a drastic number of improvement. What we saw at the startup, there is this fun Java 17 thing where the add opens. If anybody's played with Java 17, you know that everywhere you go, you see this stack trace that says, you're like, what is this? It looks like my application's dying. It's just a Java 17 thing. And so to get rid of it, we would do something along these lines, not that. You have these build args, so you probably have these peppered all over your world if you're using Java 17. So yeah, that's all that exception was. What else?
Okay.
Let me stop that real quick so it's not. Okay, cool. And then back to here.
Okay, and now if you have questions, yeah?
Talking about the transaction support, does C pretty much say within the within the Pulsar itself, or you see kind of conjoin a transaction with your database?
Yeah. So the question is, will we be able to mix Pulsar transactions with other systems like the database? And distribute the transaction with the transactional annotation from Spring?
Yeah, and so the built-in support for Pulsar transaction is just within Pulsar, of course, and then we're going to extend that into the XA transaction so that whatever it depends on the transaction manager that you have configured in Spring. So if the transaction manager that you have configured in your application is an XA transaction manager, it'll enlist in that JTA transaction, and there's a way to do it with the @transactional on your business method, and then it'll get in line with that. So, yep.
So is the transaction support both on the producer side and on the consumer side?
Yep. And so Pulsar provides the ability to do consume, process, and produce and send transactions, so that you can read, do stuff, and send. And so that's their built-in support. And so we're going to basically the way that it works is up on the consumer, on the producer, on the client. You get a transaction ID and you set it along those pieces. And the way at the end of the transaction, Pulsar, the transaction manager or coordinator will see it and say, "Oh, let's wire. You're enlisted, and it'll do the right thing to make sure that everybody is in line with that transaction." And there's also on the resources here, if you dig into through one of these links here, you'll find a link to Pulsar, and in their documentation, they have really good diagrams that explains the transaction thing I was just trying to explain much better. So yeah.
This is not regard to Spring Blackboard question, but it's basically for Pulsar versus Kafka. It's streaming side of it. You know what I mean? Is it trying to compete be better than Kafka or
Well, so what about Mary's talk? So there's a talk coming up that's all about Kafka and Pulsar, and that would be a great one because I'm sure Christophe has some opinions there.
Yeah, so of course, I'm an Apache Pulsar committer, so I will tell you that Pulsar is much better. So I would say that in terms of performance, they are comparable. But what you get in Pulsar is, so it's more recent, so it has learned from the things from Kafka that are hard. I can name a few. So we talked about tier storage. This is built in Pulsar. We talked about the schema registry. This is built in Pulsar. Multi-tenancy. So in Kafka, there is no way to do a good multi-tenancy. So, but in Pulsar, this is built in. So those are features, and there are some things that are really that really come from the architecture of Pulsar. The fact that the storage and compute are separated, it means that there's a better storage management, in my opinion. And for instance, you don't have to rebalance topics. If you've done Kafka at a high scale, you've necessarily been into this problem of rebalancing topic. In Pulsar, there is not this problem because Pulsar uses Bookkeeper, and Bookkeeper does segmentation of the log. So the storage is not bounded to the disk. It does a logical separation of the storage. So when you add a new bookie, it can be used immediately to get new topics.
What about partition? Like, the problem that we have to deal with.
So partitioning is not, you don't, in Pulsar, you do not partition so that you can scale your consumers. This is what you usually do in Kafka. because you can only consume one partition per in Pulsar, depending on your subscription mode. But there are some subscription mode where you can scale your consumers independently of your partitions.
Pulsar is more flexible. So that's in a nutshell. It's way more flexible around partitioning and configuration and all the above.
And one big feature that I showed before is that you can do both message queuing and streaming in Pulsar. You shouldn't use, in my opinion, Kafka to do message queuing, although some people do it, because you cannot have competing consumer that acknowledge individually your messages with Kafka. In Pulsar, this is possible. So this is why, for instance, we can support protocols such as JMS or AMQP, because those protocols assume that you can acknowledge the messages individually. And this is why you do not have this kind of protocol with Kafka.
Okay. And yeah.
You're having on-premise, right? And you can install all the infrastructure like Kafka, similar to that? This Pulsar infrastructure.
Can you repeat? I didn't see that.
We are not using cloud yet. We are having on-premise servers. So can we install Pulsar there happily?
Yeah, so the question was, can we use Pulsar
on-premise?
On-premise, yeah. So Pulsar is an open source project. You can go to github/apache/Pulsar, download it, or there are binaries also available on the Pulsar website. You can use it right away. There's a Docker image. So
comparing with Kafka, right? They have Zookeeper to be installed, and also here we don't need anything to do that.
So I'm repeating the question. So the question is, do we need to install Zookeeper? Yes, for Apache Pulsar. Well, okay, I see Tim saying, okay, you need a metadata store, and currently it's not built in the brokers. It's an external one, and you can use Zookeeper because it's the historical one. You can also use etcd. So the advantage in Kubernetes, you probably already have etcd, so you can reuse it for your Pulsar cluster.
And any minimum Java?
For Pulsar, it depends on the Pulsar version you're using. The latest Pulsar that was released is based on Pulsar on JDK 17. For the brokers, for the clients, there's backward compatibility. So there is backward and forward compatibility, which is guaranteed on the protocol side for Pulsar. So it means that you can use a very old client with a brand new broker, and you can use a brand new client with an old broker. They will work. And the Java compatibility for the client is Java 8.
So we are trying to move to Kafka currently. So do you suggest we move to Pulsar than Kafka?
So again, my opinion is not very objective on this, but yes, of course, use Pulsar.
To make it into standards. Anyhow, we are moving, right? So to make it in market standards, it's better to move to Pulsar than Kafka.
So if you have concerns about the ecosystem of Pulsar, which may be less than Kafka, because Kafka has been there for longer, know that you can Pulsar can go the Kafka protocol. So it's possible to use everything that exists in Kafka, Kafka Connect, KSQL DB, etc. You can use them with a Pulsar broker.